Hello, welcome back to Brains, Minds, and Consciousness. Um, let's let's get into mind. Um, Before we went on an extended and bizarre break, we were talking in person about. First, we discussed most recently the case of several people who had split brain surgery, right, and how that affects their experience of the world. Um, Before that, we got into the beginning of introducing the concept of mind. What is it? What kinds of features does it have? Related to brain but distinct from brain, and we got into a little bit of this historical back and forth we see from some philosophers, and that hand me downs from Socrates and company. So let's get in today to the questions of the history of mind and how it has sort of progressed to a more modern take. So let's get into it. A historical problem for all of cognition has been the question of, we have this mind, right? And many of the older philosophers believed that it's this distinct, important thing, a lot of dualism. And it is unique in the way that it functions above and beyond just the body. But the question is, how then does that sort of mysterious mental world actually interface with the real world? Clearly, the body is somehow involved, right? It is the conduit to actually experiencing the world, but it's not clear exactly how that works, right? It's very difficult to capture because it's tough to observe the mind, it's tough to observe the world, let alone the mind. So this is where we start to talk about the scientific method, and how, if you recall the emanation hypothesis, how that evolved into a more modern take that really much more captures how we approach understanding the way that our brains take in information from the world and pass it along, in a sense, to the mind. So, Hassan ibn al-Haytham, I think I got that close, was an Arabic mathematician, and one of the earliest advocates of science proper. So, taking concepts and reifying them with evidence, and then building new concepts, concepts, evidence, yay! That bootstrapping of how to get from total ignorance to something resembling modern science. And what he did is he began with the old emanation hypothesis. To remind you how that worked, that's the idea that my eyes blast out some kind of ray that then will somehow return copies of the world to me to use in my brain, right? Because somehow the tree is getting into my mind. And the initial idea way back was, well, maybe our eyes are just shooting lasers, right? It's not that unreasonable, guys. It's not the best approach, but it's not, they had no way to measure this kind of stuff. And they had to have some way to get copies of the tree into your face, into your eyes, into your mind, right? So, his process gradually brought us to a modern theory of reflected light. So, his approach matches closely modern science. We won't follow every single step he took, but it was an iterative process to get to the idea that, okay, it's not our eyes shooting anything out. Light is the key. Light is a sort of, it's shooting out something, difficult to measure, but something, and it hits objects. Those objects then continue to shoot the light, right? Reflected light comes off of the object. It's changed in color from however that material science works. They weren't sure yet, but that's the basic concept. So light hits the tree, And then light continues into my eyes, into my iris, and then through the back to the retina. Now, they hadn't yet done all the examination of the retina and all that, but what it came down to was this interesting point. Our vision is pointillistic. You may have heard that in art class. This is what we've covered already in the idea of the retina, right? It only has so many sensors, and they're all picking up different amounts of light. So the vision that we have is pointillistic based on how much light is hitting each different space, each different spot on the back of the eyeball. Another piece of this is that they determined that, well, shoot, the light comes in upside down and reversed. So the top of the tree hits the bottom of my iris. Ultimately, this doesn't matter because the way that our neurons are wired up to our brains, I mean, who cares, right? Just because the TV is upside down doesn't mean it's not playing the same picture. But this was weird. This is weird, right? We typically think of the world as, and gravity as consistent, but it's still, that was a big finding. And also, a final piece of this is that it was only two-dimensional. So any given retina is only getting a two-dimensional image. You are not getting the whole depth of field of the real world. You can't see necessarily 3 dimensions in a single eyeball. It's just not possible. You don't get that depth information. You do get it from other things, like you move your head and you have parallax. You can see sort of the way things move relative to one another gives you depth information. But really, this scenario is showing us that, oh, shoot, so the thing that comes into my eye is a dot pattern that's upside down and backwards, and it's two-dimensional. That is critical for understanding this big deal of, oh, shoot, that means that what I'm seeing with my eyeball is not what's in the world. This is one of those points for philosophical conundrum. So the idea is I still experience the tree as fairly coherent and complete, right? I still can see that it has depth. I can tell that it's tall, not just very close to me and not just far away, or whatever, however that translation works. I have a fully formed understanding of the tree in 3D space, but I'm not getting that in my eyeball. I'm not getting that pattern. I have to do some other kind of work inside the brain to make sense of the tree, because all I get is two-dimensional weird upside down patterns to make sense of the world. So this is cool. I mean, this illustrates the outline of, whoa, we need to make sense of how this process happens and what happens after the eyeball, right? So we'll keep rolling. Spread of scientific method comes around. A few hundred years, we start to see more and more sciences take shape and really get developed. Astronomy, chemistry, physics, all of our good friends. Western Europe, are beginning to see a pattern of trying to apply scientific method in more places to explore and explain natural phenomena. So the big approach that's coming from all these folks is this idea that you can explain these things with math, which is very cool, right? I can explain natural phenomena by creating relationships, right? The explanation of, for instance, gravity, that's a mathematical relationship. I can tell you how far the ball will fall after letting go of it, because I can observe mathematical relationships of the position of that ball over time, right? And that gives me the acceleration downward for gravity. So that's just an example of one kind of mathematical model of the time. And the idea is you can explain all of this in terms of mechanics, things that sort of mathematically or algorithmically fit together and affect one another. Every phenomenon in the world causally influences and is causally influenced by other phenomena. There is some mechanism by which they operate on one another. And here's a little conceptual chart. So a tree creates the thought of a tree, influences the person to behave and think about the tree in many possible forms, and give it, transform it into something that the mind can use, etc. The idea being that these are all mechanical processes. Not There's no mysticism, there's no magic. It's just process. So how did this begin to develop? We start with Hobbes, and he extended this idea, that, like I just explained, the idea of, motion can be described in geometric terms, right? Parabolas can describe patterns of motion, right? And he kind of carried this concept forward into, well, thought is a computation process, in a similar vein. I can capture thought as a mechanical computational type process. So he thought, all mental processes are these mechanical things, internal versions of speaking, so sort of an internal monologue, or calculations on paper. Because if I can do math in my head, maybe I'm doing some kind of version of that, or rather, if I can do math on paper and do it in my head, I'm probably doing something similar together, right? These ideas aren't terrible. Right, like we have a lot of evidence in modern times of, people have an internal monologue of sorts. It's even measurable. And we have ways of holding space for calculations. Not like a scratch pad of a literal visual scratch pad necessarily, but these ideas aren't totally off base, but they're not very well developed. And as evidenced by his next point, is that he thinks that this motion is of sort of phantasms in the brain. The phantasm is a strange word. Basically, he means sort of ghostly representations, something, right? And his thought is that I can move these phantasms with reason, like an abacus, a mechanical process, which, again, admirable approach. You want to be able to describe things in terms of their mechanics. So he sets the stage for starting to understand, okay, something that minds do is able to move ideas around in the form of, quote, phantasms, right? So leading from that, we meet Descartes. And Descartes is well known for his like meditations, right? On, oh, shoot, I think, therefore I am, is the only thing I can be sure of, etc. Which I don't mean to say flippantly. That's an important concept. But he was a philosopher by trade. He had a lot of ideas here. So he elaborates to say, what external worldly things can actually turn into internal physical motions. Physical in the terms of, like, hey, this is a mind is certainly existent, so are there physical properties inside? And he comes in with the doctrine of corporeal ideas, is that being a bit of a dualist, he has this concept that our minds have awareness of the states of our bodies, and that awareness passes through the body. So we sort of capture the world from mentally observing our bodies. Not a terrible thought again, right? That somehow we're trying to capture, where does the mind live exactly? What is it operating on, and how does it interface with the world? And his thought, again, is the mind is non-corporeal, but it's the ghost that lives inside of the meat. It sounds kind of flippant, but it's kind of the best way to capture the idea. We can let him speak for himself briefly. So, Descartes. So I'll try to put on his style, right? What's this guy like? When the picture thus passes to the inside of our head, it still bears some resemblance to the objects from which it proceeds. However, we must not think that it is by means of this resemblance that the picture causes our sensory perceptions of these objects, as if there were yet other eyes within our brain that could perceive it, right? Instead, we must hold that it is the movements composing this picture which, acting directly upon our soul, insofar as it is united with our body, are ordained by nature to make it have such sensations. What is he getting at here? So, he's saying it's not just the resemblance of the patterns that we take in, because that doesn't quite track. It's because he's talking about something that we're going to get into in a few minutes, which is, we can't just keep saying, you can't pass the buck back, right? It's not that some other thing inside of our mind is observing the same pattern. What he's saying is, whatever the mind does, it's interfacing with the body in a different way than just, say, seeing the same picture that the body has observed out in the world, right? So what he's onto is, he thinks that the mind is actually perceiving not the retinal image itself, but some, quote, energetic effect that image has on the nerves. Okay, we're getting somewhere. The reflected image, it's not necessarily the same as a stimulus, but it doesn't so much matter, because it's the way that stimulus changes the neural firing that matters to the mind. This tracks more and more with modern takes, because, again, it's not just a jiggling of the nerves, but this was the best he could describe it at the time. It's the idea that the mind picks up on the patterns of neural activation. It doesn't matter what the shape of the image looks like. It doesn't matter that it's two-dimensional. It matters how that shape on the back of our retina starts to trigger the rest of our neurons. So, yeah, it's good stuff. It's good ideas. These were, strong thinkers. So he goes on to propose a few different kinds of sense. He calls them his grades of sense, Descartes. The first grade of sense is the idea of just purely mechanical senses coming in to the body. Just the light hitting the eyes, causing some change, right? That is the first way to consider a, quote, sense. The second, he says, is the subjective awareness of the body. So whatever's happening in the body, that whether that be pretty much neural firings, most by and large, your sense, your mind's sense of it, comes from that direct observation of the body. So not necessarily the first sense, right? The first sense is just thoughtless mechanical thing. The second sense is this sort of subjective, I'm picking up what the body is putting out. And then third, finally, is this sort of the leap between the two of, okay, because the mind is able to observe the body and the body is able to mechanically observe the world, I have some kind of objective awareness of the states of the world, right? So getting more into that, so again, the first grade is physical. Like, it's just the physical processes, right? And the physical world is, light is bouncing around, bumping into it. I'm touching my arm, etc. And then the third grade is this purely mental grade of, I have understanding of the world outside because I have, my mind does, because it has done, jumped through all the hoops to gather this idea. And then the second grade kind of connects the two. It's the idea of, well, what is the mind actually seeing? Well, it's seeing the way that the body is indirectly influenced. Or rather, it is indirectly perceiving the world by seeing how the body is influenced by the world. Okay. So, this isn't a bad take. The graded senses, even if we are purely mental, right? By this, in this worldview, that it's very much taking the I, the self, to be this sort of mental, worldly thing, right? And I'm only really directly aware of my body, but I can still make sense of the outside world and produce appropriate actions, right? So, it's this indirect process of whatever my mind's doing, it's living somewhere in my nerves, dealing with directly with them, while the world influences my nerves. This is okay. Um, so, this, remember, was a time, though, of trying to make thought mechanistic, right? This is science. We're trying to come up with mechanisms to explain how these systems work. So the grades of senses need a sort of mathematical representation, a way to capture what this is talking about, that then can be abstracted into relationships, right? And this is, the abstract relationships don't need to bear perfect resemblance to the concepts of the mind and the body and all this. It's mathematical, right? It's theoretical stuff. So the question is, how do we construct a sort of a theoretical take on this? His ideas are nice. They ring true to an extent. It's like, okay, if I'm a mind, I must have view of the world. There's got to be some kind of interface there, right? So how do we capture this? How do we get the ideas of these senses and the reasoning over them into a complete understanding of the mind in a mechanistic world? So this is where we get into his concepts for how you could approach this, right? So he says, to start, you need a mechanical account of all the grade 1 type sensing, right? You need to understand physics, biology, etc., to explain how that information is generated, right? And we spend a bunch of time in Brain talking about this. We have a really good understanding of this these days. Back then, this was a sort of a conjecture of this is what you would need to make sense of the mind in these terms. Then we take a step into what Descartes calls endowed knowledge, which is the idea that, okay, if, think about a baby, right? A baby is born into the world and they have a few automatic processes, but mostly they're just, they don't know anything from anything. So they are trying to make sense of the world around them, and eventually they learn to. In this world of the graded senses, it's kind of hard to figure out exactly where does that knowledge come from. Because to make sense of, give or take, your senses, your like physical senses, you have to have some way of making sense of that, right? Pardon the continuous puns. There will be tons of them, but just throw them away. We have to make sense of senses. So, okay, so remember the mental sense of, okay, I need to be able to process the world. I need to be able to look at what's happening in my neurons as a mind to be able to make sense of what's going on outside. So what do we actually start with is the question of identifying endowed knowledge. What does the mind come with to actually help it make sense of the sensations coming out of the grade 2, right? Which is not an easy question to answer. And then finally, once you've nailed those two, you now need to kind of stitch them together. What's the actual process of combining grade 2 sense with that endowed knowledge to make sense of the world? So, combining that all together, the third grade of sense has to have some kind of rules for manipulating the symbols that it's pulling out of the vibrations of the body, right? The bodily vibrations from sense 2, grade 2. This paints a picture of a fairly common thought in a lot of cognitive science over the many years, and that is a rule-governed mathematical process of reasoning, right? We are saying, I have endowed knowledge, I have ways of absorbing knowledge from the world, and I combine them in an algorithmic abstract way, and that is a mind. That's great. That's cool. But it leaves some things to be desired. Also noting that this is the precursor to the physical symbol system concept, right? We are getting to the idea of how does the mind move information around? How does it process the world and make sense of it? But there are a couple of issues with Descartes' approach. First is, this is nice. We should cast it first as it's good because he's created this mechanistic process, right? He's attempting to describe every step from the physical processes of the world, which we can capture very easily, to the endowed knowledge that would have to exist, to if I can combine the endowed knowledge with the actual physical processes, I can create a mechanistic approach to understanding the mind. Cool stuff. But there's a couple of big issues. So, first is infinite regress, which is also known as the homunculus problem, and the second is the paradox of mechanical reason. So, we'll start with the homunculus problem. The man in the inner room, if you have not heard of the homunculus. So, here's the issue. When I'm trying here to explain how humans reason, and Descartes attempted to sidestep this, but I don't think he succeeded. That is, if all I'm saying is, hey, the mind is observing the body to make sense of it, how is that any different than the way the body is observing the world? I mean, in a sort of a simple sense, right? How then does the mind reason over it? How does the mind just keep passing it to some other internal reasoning mechanism? The issue is, I can't explain how reasoning works. My reasoning is sort of the catch-all term for thought, by saying some other component does more of the reasoning. It's the idea of infinite regress. If the goal is to explain the processes of the mind, then all we've said is, well, the mind is observing a bunch of cool stuff, and then some other part of it does the reasoning. That's not satisfactory. Who's the mind's mind? Who's the mind's mind? And so on forever, right? So I hope you're seeing this pattern. That is the problem with the idea that we have a little homunculus flipping switches in our brains, is that if that's the explanation, then how does that homunculus work? What is it doing to reason? What is it doing to make sense of its tiny world? And if it just has another homunculus inside, well, we're screwed. Now, that said, as it gets more sufficiently abstract, you may hit a sort of upper bound, and you can find a way to say, well, there is a point at which it stops. There is a maximum level of abstraction, something. But that's really, really hard to pin down. So, we see an issue in infinite regress and the homunculus problem. Next is, this one's interesting, the paradox of mechanical reason. How exactly, even giving space to the homunculus, saying, hey, fine, the homunculus of mind is in there, and it's making sense of the meaning of symbols in the world. Let's look at this example. We have the mind observing two different scenarios. 1 + 1 = 2. That's clear. That's a mathematical addition process, right? We also, if you've done some programming and some other things, this actually makes sense. 1 + 1 = 1, because that can also mean concatenation, right? I take the two strings, more or less, the two symbolic strings, and just put them together. Okay? If you've done programming, you've seen something like this before. But the question is, I understand the difference between the plus signs in these situations, but they're not physically different. What's going on? Here's the trick. Meaning is this abstract idea, and it's not exerting any physical force on the world, right? But mechanical processes are driven by these physical forces. So if this system, this ghost in our shell, is actually attending to the symbol's meaning, somehow abstracting out that meaning, then there's something that's non-mechanical happening. and thus we can't, this is not a mechanical mind. There's still some bizarre abstraction happening. But then, if it's ignoring the symbol's meaning, well, then it's failing to reason, because we know there's a difference between those two symbols. Which is it? There's a conundrum here. How exactly is this mechanistic approach to understanding the mind? How does it make sense of that plus? So this gets into a fairly abstract realm of the origin of meaning. So Descartes was a religious man, so he was satisfied to say, well, the secret is God. God is giving us that connection, which is fine. He did enough work in his life to explain things. He doesn't need to keep digging. But that's not especially satisfying. So empiricists were a group that kind of took up this investigation to try and figure out what's going on. How then does meaning come into play? How do we mechanistically arrive at meaning? This is tricky. This is the whole kind of tricky part. Because we have, quote, understanding of the world. We understand the meaning of many things. How do we achieve that? Where does it come from? Certainly experience must play some kind of role, but what is it? And again, we're trying to make a mechanistic account, a scientific mechanistic account of the mind. So the empiricists come about and start giving us a bit of that. So if meaning isn't just this God-given thing, how then does our friend, the mind, the homunculus in the mind, obtain knowledge? And that's where we'll keep going here. So the man in the room, remember the homunculus, remember our friend. He's trapped up in this house, this weird little house, right? And his only knowledge of the outside world comes from cameras outside leading to screens. Now, that's an abstraction. You can think of this in terms of the brain too, right? My eyeballs are giving something to my brain, right? What then does it do with it? And more importantly, what does it consider real and useful and important? That's the very first question of meaning is, hey, are these images real? How much of it is, just artifacts of the communication system? For instance, if I was, partially blind in one eye, I would not trust my video screens to give me the perfect view of the world. But even under ideal situation, what's the role? How much does it matter? How much does, the system of various connections to cameras and my screens, how much does that play in my understanding of whether the outside world is trustworthy, right? So, the man in the room, and this is getting at an ontological question, that is, what is real? This is the very first step before you can achieve much in the way of meaning. You gotta understand what's the real thing. Is the outside world real at all? Are the images real? Is the wire connecting them real? Where does the real part live? And what's the relationship between the outside world, the images, and potentially the wiring? So this is a strong question that leads to a lot of investigation and debate and discussion. So we will talk about the discussion here. First, we get into Locke. You may have heard of this concept before. Tabula rasa. Locke said, "We are blank slates. All knowledge comes expressly from worldly experience. The homunculus is a realist. The outside world is real." And the whole goal of the homunculus and in it building its meaningful understanding of the world is everything to do with consistency. What is consistently occurring outside? What can I see with any consistent pattern, right? So this leads us into a discussion of realism. Knowledge consists of ideas that are the result of sensations. Pretty good concept, I think. Not off base here. And the beginnings of this say there are two kinds of simple ideas. There's primary qualities. These are just the things that are true of the world, whether anyone's there to see them or not. The size, the shape, the motion of things. That Pluto doesn't care if we know about it or not. It's moving. It doesn't care if we call it a planet. It's a big rock moving through space, right? How many of a thing are there? There's always going to be 10 trees in that copse or whatever, right? So then there's secondary qualities, which are more things that we sort of process out of things in the world. So there's the things that exist independent of us and things that exist given our subjective experience of them. So color and taste and smell and sound and a lot of the sense things. Now, these things are tied together. I mean, I observe size with my senses, and I can be fooled and all that stuff. But the idea is that these properties of actual things and our understanding of the properties of actual things are what give rise to complex ideas, more consistent understanding of what all is happening in the world before us. So, letting Locke give a little bit of a chat here. With these simple ideas, it has the power to repeat, compare, and unite them to an almost infinite variety, and so can make at pleasure new complex ideas. But it is not in the power of understanding, of thought, to create or frame one new simple idea. What is he getting at here? So, what he's saying is that it seems a little bit strange to say, oh, all knowledge consists of like lengths and shapes and counts and colors and stuff. But what he's saying is that's fine. That these are the most very simple ideas that exist in the world in this simple form. I can't create new ones. These are properties of the world, and all of my other ideas are combined. For instance, think about the last car you saw. That concept of the car, now some of you may have different abilities to visualize this, but that concept of the car came from its shapes and angles and, combining two ideas of, oh, this piece of it is at this distance and this piece of it at this distance creates an angle. That angle is part of a bigger shape, right? You combine all of these ideas from the real world into a more complex concept of a car. Oh, and that car moves, and it moves fast. I have all these thoughts about this car. But they're all composed explicitly from the simplest ideas. So, this is the realist approach. Everything comes from the ground up, directly from the world. Berkeley talks about the opposite approach. He says, hey, this homunculus needs to be careful. There's no guarantee the world exists at all. In fact, there's no proof to a given internal observer that the world exists. Remember what we've talked about from the Descartes approach a little bit is the outside world is only influencing the body, and the body is then influencing the mind. Anything could be projecting into these screens. Anything could be causing the stimulation of the nerves. We could just be a brain in a jar and have nothing else, and someone is just giving us this information. So what Berkeley's saying is that the homunculus is an idealist. So idealism is easiest explained just kind of in contrast to realism. Idealism says reality is not, it doesn't really track. You don't have to think about what's happening outside there. The simple ideas and the complex ideas thing, the only thing that matters is what's on the screen and the ideas they produce. Just the connection between the brain, between the mind and the mental, information center. No external information is viable or even considerable in idealism. And there's no evidence to the contrary. And unfortunately, that's a tricky thing to defeat. If you've seen The Matrix, this plays into it quite a lot. But yeah, it's the idea that you can't be sure. You just can't. There's a struggle to that. I don't particularly buy into it, but it's still the strong, the philosophical argument stands to some extent. So let's contrast these two, idealism and realism. Idealism, only ideas are real, nothing outside can be certain. But realism says there's only the outside world. Everything else is this sort of illusionary sort of, it's all built up explicitly from observations of the outside world. Now, there is multiple middle paths, and we can talk about someone who walked one of them. Hume comes in and says, okay, look, we know that the knowledge must come through the screens, but unlike realism, we know that almost all of the knowledge must be filtered by the screens. There is some internal way that knowledge is being handled, and it's not all explicitly from the simple ideas of the world. But in contrast, the information isn't random garbage. Idealism says, oh, the world cannot be known, but you look at the tree every day, it's still the same tree. It's not just random gibberish. You're getting the same tree. That consistent observation matters quite a lot. So what Hume says is this mental homunculus, is a skeptic. It acquires knowledge by looking at the structure and patterns of the screen's information and then using that to sort of triangulate the idea of the outside world. Accepting that there can be flaws in the way that the system brings information in, but also saying it doesn't matter that the flaws are there, there's still patterns, and we can make sense of these patterns. So skepticism is more about there are consistencies and regularities on the incoming information. The same things will recur at the same times in the same forms, and this is giving us hope that outside world actually exists. Whether we're being fooled or not, that's a matter for the Matrix. So, So Hume comes out kind of against the homunculus. He doesn't like this concept, and what he digs into is there's no magical rational agent hiding inside. What he digs into is by combining this these thoughts from idealism and realism into a more skepticist approach, says you don't need a secret person inside. Sensory information doesn't need to be processed and organized by some other hand. It can just use these sort of simple laws of association. We talked about these in, I believe it was the Plato era, in the last lecture. Similar to the laws of physics, there are, as long as things are occurring that are similar to one another, we can make sense of their resemblance. Well, they occur next to each other, we can sort of build ideas off of that, and the idea that things might cause one another. We'll talk about these in a moment. Now we move on to Helmholtz, who, again, takes this torch and moves forward with it, and kind of pulls all these concepts and ideas together to the most modern understanding of mind that we've seen so far. So, first, he gets into trying to update that doctrine of specific nerve energies from Descartes, which we'll look at in a moment, and then also dig into a new version of those laws of association that help to sort of capture the world and how we build knowledge out of it. So, first off, he revises this doctrine of specific nerve energies and says, okay, look, it doesn't matter how a receptor is stimulated. It doesn't matter how any individual pattern occurs into the eye. But what he brings to the table here is all neurons produce the same kinds of responses. Responses are specific to nerves. They have nothing to do, they don't care what the stimulation was. They're just nerve responses. This is big. This is modern neuroscience, right? I mean, the dawn of. So it's the idea that sensations that the mind actually is perceiving and like making sense of don't resemble at all the event that caused them, because it's not accessible to them. The eye, once the patterns leave the eye, they're just neural firing. And that's big, because he's kind of doing away with this idea that there is some magic to the way that, the representation of the tree must survive on its... It doesn't need to. We reconstruct everything from these very simple neural patterns, which is huge, because we know that to be much more the case these days in really life. So he also updates and gets into the laws of association. So this is giving a take of how do we make knowledge, right? Remember, this is the question of where the heck does meaning come in? How do we connect meaning? And so what Helmholtz is saying with his approach to the laws of association is sensations that occur in certain ways connected to one another become then connected in memory, right? And so the three rules are the same as before: resemblance, contiguity, and causation. Let's look at resemblance first. So this is the idea that I can associate two ideas that have something in common. I can sort of build a new concept that, these two ideas are related to one another. So, for example, an artist drawing flowers makes us think of flowers because it has many of the same properties. It has the same sort of silhouette, the outside edges of this flower. It has some of the same colors, right? Same shapes, all that stuff. But ultimately, it's just a flat 2D mass of paint smeared on a canvas. This idea that these two things map together in our minds is the idea of resemblance. We can say, these concepts make sense together. I have an understanding that these things are related because they bear a resemblance. And similarly, to a slightly different point, is we can relate cats and dogs, for instance, right? They're different animals in so many very important respects, but they're both furry. They both have 4 legs. They both, have whiskers. We can connect them as related based on what there is that is similar about them, right? So this is the idea that meaning meaning and knowledge can come from the idea that I can connect ideas based on their resemblance. Another one of the laws is law of contiguity. This is the idea that I can associate ideas that are near to one another in time or space. So, for instance, salt shakers and pepper shakers always come together, right? They're always on the table together at the diner. They come to mind as a set, right? I think of them. It has nothing to do. They happen to be similar, but they contain totally different things. They sit together. They always occur together. So I think of them as a set. I connect them in my mind as related, right? Similar about time, right? A flash of far-off lightning is always often followed eventually by a roll of thunder. So we combine them into this same concept. We don't think of them as distinct, totally unrelated things. We can think of them as, there's something there connecting these two. There is a concept there. There's knowledge there. Lightning and thunder to go together, right? That's useful information. That's an idea being born. If the first few times you see that, if you live in the wild, you might be confused and think that the gods are angry, etc. And you probably still would, honestly, but you'd start to connect the two pieces pretty quickly because they always occur together, right? It's not at random that thunder and lightning connect. They always connect. So it gives you the basis for understanding, okay, what are the features of this thing? What other knowledge can I acquire about this thing, right? I'm hoping you're seeing how these laws give rise to ideas that can be elaborated, right? The final law is causation, and this is key. This is big for science. It's big for our personal science and understanding how the nature of the world works, right? Because one of the best ideas you can have is, this thing causes this thing, and it allows you to predict things that might happen in the world around you. That's pretty important. In fact, all of these kind of give rise to that to some extent. But if I see lightning flash, I can say, thunder will come soon. But this is about causation, right? By doing a thing, I can cause another thing to occur. So it's especially possible across like long distances of time, but it's much easier when it's closer together. So, for example, there's the very proximal cause and effect of, if I get near the snake, it seems to cause a lunging bite soon after. So that's important intel. That's an important idea. That's important knowledge. That's important meaning for this particular set of patterns, right? I have knowledge about the snake on my internal screen that says, oh, no, we need to get far away from it because it's going to bite us, and biting is bad. Biting leads to very bad things. Another cause and effect. Similar, but a little bit slower, and illustrates hopefully the idea that this is kind of hard to track. Eating certain berries will make us sick tomorrow, which is a longer delay, but it's still, you do it enough, you start to realize, oh shoot, I got to stop eating the purple berries. So this is, again, another idea we can use for safety, which again gives more meaning to the world on the internal monitor display, right? If I see purple berries and snakes, I think, I gotta get out of here. This place sucks, right? Like, that's useful. It gives meaning to the patterns on the screen, which helps to make sense of the world. So, connecting these dots, these laws and ideas together, what is this actually giving us? This is a way for stimulus can enter into our system expressly through the nerves. It's this very simple information. It's not complex copies. It's not something sort of mystical and strange about bringing a tree inside my mind. It's neurons just firing. And then on top of that, he's given us this framework for how new knowledge can arise exclusively from combining things in the world, right? You don't need special endowed knowledge to say, berries make sick. I hate this, right? Sick is an unpleasant feeling by nature. I understand the causation of berries and sick. That's super useful, right? So, and again, to reiterate these things, X and Y are similar. That's knowledge I can contain. Y occurs before Z. Y seems to cause Z. That's at least something that I could observe in the world. Now here we go. X might also cause Z. That's a hypothesis. It's not something we've directly observed, but it's something that we can create internally that tests the world, that gives us a question that we can evaluate in the world, a prediction that will help us make more knowledge. And I've just explained to you in a handful of words all of science. Predictions that help us obtain more knowledge by testing them. That's great. So, science is more than that, but still super important. So let's just look at this again. Stimulus exists there that causes some kind of activity in the receptors, and then those specific nerve energies travel to our internal sensory, whatever, our screens, right? Our whatever the mind is handling, and that allows us to make these predictions, these hypotheses, and then all interact with associative memory to say, hey, from memory, I think that those berries are probably going to be bad. And then if I test that and I eat the berries and, oh, wait, they were good. Maybe I was wrong. I update my memory. This is a very strong approach to understanding how the mind can derive meaning out of the world around it. So this disjointed, sort of inadequate copy of the world, plus our rules and experience about the world, that consistent set of patterns, despite how disjointed and inadequate the copy is, we continue to make sense of the world through it. And so with our growing repertoire of knowledge and rules and experience, we come up with hypotheses that we can test and build our knowledge and rules. We are inherently scientists. This is like huge. This is big for our development as a species. It's key to the way that we handle this stuff. So this is an approach that helps to sort of pin down how the mind rises from this. So, taking that back again, this is understanding the world through our perception, and that is forming hypotheses about what the heck's going on out there. What does this mean? How is this connected? What does that connect to that, etc. And then choosing the most likely events, combining that with our sensory input and our experiences, and then adjusting our understanding of the world based on the things that we observe in it and the accuracy of our own predictions. So now we return to the question of how then do we consider the representations of the mind, right? And we still need this concept, because we've gone from just I can create copies of trees in my brain and I can think about them and reason over them and etc. to a different take. How exactly do our hypotheses stored? How exactly is our knowledge stored? What kinds of knowledge can we actually even construct? And this touches on a key idea in all of science, but especially in this mental world of how do we model the outside world in our neurology, right? We've talked about how, I can summon up a visualization of, some of us can summon up visualizations of, oh, I remember the last car I was in was this color, right? How do I access that? How did I build that model? How do I have that understanding? What am I doing with it? And, how do I construct this model of the world around me and make good ones, right? How do I make good mental models of the world that allow for this successful interaction? So the idea being that we need to understand the process that allows for that modeling, that mental modeling, to actually occur. How do I build that mental map of the world around me? And that's the topic of another lecture. So thank you for sticking it out. This is tricky. It's a little bit of fun. I'm doing a lot of editing on the fly while I'm recording it, but look forward to more soon. I'm getting this down a lot better, and I think that we'll have plenty to talk about. Remember, office hours. I'll be updating those soon. Actually, I want to hold them at a different capacity than I have been. So, but take care and look forward to the next lecture.